Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Hope you all fine. Lecture for grade 8, subject chemistry, chapter number 2, exercise, lecture number 14, and here is Mrs. Saira Jamal. Exercise of chapter number 2, question number 1, encircle the correct answers of the following. First MCQ is, according to Bohr atomic model, each orbit has fixed energy, so each orbit is called sub-energy level. Is this statement true, or is this statement according to Bohr atomic model? The answer is no. Why? Because each orbit has fixed energy, so each orbit is called energy level, not sub-energy level. Sub-energy level is for subshell, not for the shell or not for the orbit. So this is wrong, and this statement is not about the Bohr atomic model. Second statement, the energy of the electron is inversely proportional to its distance from the nucleus. Again, this statement is wrong because energy of electron is directly proportional to its distance from the nucleus. It is one of the postulates of Bohr atomic model, which state that farther the electron from the nucleus, the more energy it has. So this relationship is direct relationship, not an inverse relationship. C. Light is absorbed when an electron jumps a lower energy orbit. Light is emitted, not absorbed, when an electron jumps a lower energy orbit. Light is absorbed in that case when an electron jumps from lower to higher energy orbit. Option D, the further the electron is from the nucleus, the more energy it has. Yes, this is the correct option. Further the electron from the nucleus, the more energy it has. And electron jumps from higher energy level to lower energy level. You can see from shell number 2, when electron jumps into shell number 1, it emits energy, not absorb energy. And further the electron from the nucleus, you can see the electron which is present in the third shell, it has highest energy. That shell has highest energy, so the electron will also have highest energy. And the one which is present in shell number 1, which is closest to the nucleus, it will have less energy. So the correct option is D option. Number 2 MCQ. Chlorine has two isotopes, both of which have. What are isotopes? Isotopes are the atoms of an element which have same number of electrons, same number of protons, different number of neutrons, and different mass number. So the statements, option number 1, they have same mass number. No, mass numbers are different because number of neutrons are different. And mass number is the sum of protons plus neutron. 17 plus 18, 35. Mass number is 35 for this isotope, and 17 plus 20, 37. So 37 is the mass number for the second isotope. So mass number are same? No, this is wrong. Mass numbers are not same. Same number of neutrons? Neutrons are different. This isotope number 1, it has 18 neutrons, and second one has 20 neutrons. So again, not correct. Different number of protons. Protons are always same, 17 proton in this case and 17 proton in this case. So this is again wrong. D option, same number of electrons. Yes, this is the correct option. 17 protons and 17 electrons. 17 protons and 17 electrons. Electrons are same in both cases. So D is the correct option. Third MCQ, number of neutrons in an element M. Atomic number of that element is 13 and mass number is 27. I told you before that the small value of the small number is atomic number because it is only the number of protons, while the big number or the larger number is the sum of protons plus neutron. So this is mass number. So the bigger number will be mass number and the smaller number will be atomic number. So how to find out the number of neutrons? We have the formula. Formula is number of neutrons is equal to mass number minus atomic number. Mass number is 27 and atomic number is 13. So 27 minus 13 is 14. So number of neutrons are 14. So B is the correct option. Number 4, which isotope is commonly used to irradiate cancer cell? Iodine 123? No. Iodine 123 is used to image brain. And carbon 14? No. Carbon 14 is used to find out the pathway of carbon in photosynthesis. Cobalt 60? Yes. Cobalt 60 is used to kill the cancerous cells. Iodine 131 is used for the diagnosing thyroid problem. So C is the correct option. Number 5, M shell has subshells. M shell is which shell? First shell is K shell, second shell is L shell, and third shell is M shell. So M shell has how many subshell? K shell has only one subshell, S. L has two subshell, SP, we can also call it 2S, 2P. The first one is 1S, 2S, 2P. The subshell which are present in the third shell are S, P, and D. We can also call it 3S plus 3P plus 3D because 3 is for the shell number, the value of N. We always write the value of shell number or the value of N before the subshells. Okay, so NS, NP, ND. N is 3, so 3S, 3P, and 3D. Options are 1S, 2S. 1S is for shell number 1 and 2S is for shell number 2. No, wrong option. 2S, 2P. 2 means second shell and second shell is called L shell. It is not M shell. 3S, 3P, 3D. Yes, this is the correct option. Shell number 3 and subshells are S, P, and D. 1S, 2S, 3S, they are totally wrong. 1S shell number 1, K shell, L shell, M shell. So this is the combination of 3 shell. Only correct option is C. C is the correct option. 6 MCQ, a subshell that can accommodate 6 electrons. S can accommodate 2 electrons because it has only one subshell, or which is also called orbital, and P has 3 subshells or 3 orbitals, and it can each orbital can accommodate 2 electrons, so 3 will accommodate 6 electrons, and D subshell has 5 subshells or 5 orbitals, and each orbital I told you can accommodate 2 electrons. So 2 5s are 10. F subshell has 7 subshells or 7 orbitals. So 7 2s are 14. It can accommodate 14 electrons. So what is the correct option? Is S is the correct option? No. P, yes. D, no. F, no. So B is the correct option. B can accommodate 6 electrons. Sodium has atomic number 11 and its configuration, electronic configuration will be, which one will be its electronic configuration? A, 1s2, 2s2, 3s1? No. After 1s, 2s, the third one is 2p, 3s. This is wrong. B option 1s2, 2s2, 2p. Yeah, orbitals are same or subshells are same, but the number of electronic distribution is not correct. You can see 2, 2, and P can accommodate 6 electrons. We cannot put 7 electrons in P. So this is wrong. C 1s2, 2s2, 2p, 5. Again wrong. P can accommodate 6 electrons. So this is again wrong option. D 1s2, 2s2, 2p6, 3s1. Let us check first the subshells energy order. 1s, 2s correct, 2p correct, 3s. Yeah. So energy distribution is correct, but distribution of electron, let us check. S can accommodate 2 electron, correct. S can accommodate 2 electron, P can accommodate 6 electron, 6, 7, 8, 9, 10. Only one electron is left. That one electron will go to the third shell and the subshell will be S. So D is the correct option. Number 8, Rutherford used dash particles in his experiment. If you remember Rutherford experiment over there, I told you that Rutherford used double positively charged helium nuclei. Double positive mean plus 2 charge helium nuclei. So C is the correct option. Number 9, which of the following statement is not correct about isotope? Isotope have same atomic number? Yes. Isotopes have same number of protons? Yes. Isotopes have same chemical properties? Yes, because chemical properties depend on the electrons present in the outermost shell or the valence shell. So isotopes have same atomic number, they have same number of protons, they have same number of electrons, and same electrons in the outermost shell. So chemical properties will be same, but they have same physical properties. This is wrong. Isotopes never have same physical properties. They always have different physical properties, because physical properties depends upon the mass number, and as number of neutrons are different, so mass number is also different, and as a result the physical properties will also be different. So D is the correct option. Number 10, which isotope is used in nuclear reactors? If you remember, there are three isotopes of uranium: uranium 234, uranium 238, and uranium 235. And I told you over there that uranium 235, which has odd mass number, is used in nuclear reactor. The rest of the two has even mass number. So even mass number isotopes are hard to decompose or hard to decay them. So the odd one is easy. So uranium 235 can decay, and it is used in nuclear reactors. Next question is question number 2. And question number 2 is the short question answers. Short question answers are: question number 1 short question is differentiate between shell and subshell. What are the main differences between shell and subshell? Shells, point number 1, a circular path around the nucleus in which the electrons revolves is called a shell. A circular path, if you remember, we discussed it in Bohr atomic model, that a circular path around the nucleus in which the electron revolves around the nucleus is called shell. And subshell is, it is the pathway in which the electron moves within a shell, inside the shell. It is called subshell. Point number 2, each shell has fixed energy. So each shell is also called energy level. As they have fixed energy, so they are also called energy level. And point number 2 for subshell, the shell is subdivided, or the shell is divided into subshells, and subshell also has fixed energy, so they are called sub-energy level. Shells are called energy level and subshells are called sub-energy level. Point number 3, each shell is described by an n value. It have values 1, 2, 3. You know, shell number 1 is called K shell, and shell number 2 is called L shell, and shell number 3 is called M shell, so on and so forth. And for subshell, each shell is composed of different number of subshell. Shell number 1 has only one subshell, that is 1s. Shell number 2 has two subshell, 2s and 2p. Shell number 3 has three subshells, 3s, 3p, and 3d. And shell number 4 has four subshells, which are 4s, 4p, 4d, and 4f. Point number 4, the maximum number of electrons in a shell is described by the formula 2n square. By using this formula, we can find out the number of electrons accommodated by each shell. And for the subshell, you know that subshell S can accommodate 2 electrons, P can accommodate 6 electrons, D can accommodate 10 electrons, and F can accommodate 14 electrons. So this was about the differences between the shells and subshell. Coming toward the second question. Second question is, an atom is electrically neutral. Why? Why an atom is electrically neutral means it has no charge. We know that proton has positive charge, usually expressed as +1. Electron has a negative charge, it is expressed as -1. Proton has positive charge and electron has negative charge. A neutral atom has the same number of electrons and protons in it. So these same charges, they will cancel the effect of each other. Therefore, the net charge on an atom will be 0. And this 0 will make an atom electrically neutral. Let us take the example of carbon. Carbon atomic number is 6. It has 6 positive charges and 6 negative charges. So definitely these positive and negative charges will cancel the effect of each other. As a result, net charge on atom will be 0, and this 0 will make the atom electrically neutral. Question number 3, how many subshells are there in N shell? How many subshells are present in N shell? So what is subshell? First you must know about subshell. Subshell is the pathway in which the electrons move within a shell. Okay, within a shell, inside the shell. I told you before that the shell are subdivided into subshell. So these are present inside the shell. That's why we call it within the shell. N shell is which shell? K, L, M, N. K first shell, L second shell, M third shell, and N fourth. So N is shell number 4. And shell number 4 contains how many subshell? 4 subshell, which are 4s, 4p, 4d, and 4f. So S can accommodate 2 electron, P can accommodate 6 electron, D can accommodate 10 electron, and F can accommodate 14 electrons. So this shell number 4 totally can accommodate how many electrons? 32 electrons. It can accommodate 32 electrons. Question number 4, give notation for subshells of M shell. Again, first of all, you have to write the definition of subshell. Subshell is the pathway in which the electrons move within a shell. Then you have to mention M shell is which shell. M shell is the third shell, and third shell contains 3 subshells. Those 3 subshells are 3s, 3p, and 3d. So 2 electrons can be accommodated by S, 6p, and 10 by D. Total, how many electrons? 18 electrons. So third shell can accommodate 18 electrons. Question number 5, list the subshells of M shell in order of increasing energy. M shell, I told you before, M shell is the third shell, and it has 3 subshells, 3s, 3p, and 3d. First of all, write the definition of subshell. Subshell definition, M shell is the third shell. It contains 3 subshell, 3s, 3p, and 3d. And order of increasing energy according to Bohr principle is the energy of 3d is highest, and 3 subshell is higher in energy than 3p and 3s. 3s has least energy and 3d has highest energy. This symbol, you must write this symbol, because this symbol will show the order of energy that is increasing from left to right. Question number 6, can you identify an atom without knowing the number of neutrons in it? So what do you think? Can you identify an atom without the number of neutrons in it? Yeah, obviously, because all the elements in the periodic table, they are arranged on the basis of their number of protons, means on the basis of their atomic number, not on the basis of their neutrons. Isotopes, neutrons means atoms have different neutrons, so they are isotopes. And I told you there is no position of isotopes in the periodic table. So yes, we can identify an atom without knowing the number of neutrons in it by its proton count. Proton count means by its atomic number. The neutron count tell us the isotope of that element. An isotope has no position in the periodic table. For example, hydrogen has no neutron, but we can identify it from its proton count, and we can find the number of neutrons by using formula. If we don't know, if we have no information about the neutron, only we have information about the mass number and the atomic number, so we can find out the number of neutron by using this formula. Number of neutron is equal to atomic mass minus atomic number. What is atomic number? Atomic number is represented by capital Z, and it is the number of protons which are always equal to the number of electrons. What is mass number or atomic mass? Mass number of atomic mass is the sum of number of protons and number of neutrons. Question number 3, the electronic configuration listed are incorrect. Explain what mistake has been made in each and write correct electronic configuration. Some configurations are mentioned and we have to identify that is it correct or wrong. Let us see. X 1s2, 2s2, 2p. This energy sequence is correct. 1s, 2s, 2p. Then after 2p is 3s, not 3p. So energy sequence is also wrong. And another thing is the p can accommodate 6 electrons. So instead of putting electron in 3p, it is easy, or according to our principle, we have to put 6 electrons in this 2p. There is no need to put it into the 3p or 3s. Total number of electrons are 4, 5, 6, 7, 8, 9, 10. 10. There are 10 electrons and P can accommodate 6 electrons. We will write 2p6 electrons in P instead of this 4. So correct configuration is 1s2, 2s2, 2p6. Why? 1s2, 2s2, 2p. Okay, 1s2, 2s2, 2p. Energy sequence is correct. But S can accommodate 2 electrons. So by putting only 1 electron in S and 1 in P, we must write both the electrons in this S. So 1s2, 2s2 will be the correct option. Total number of electrons are 2, 3, 4. 4 electrons, and S can accommodate 2 electrons. So we will write 2 electrons in S instead of 1. So correct configuration is 1s2, 2s2. Z 1s2, 2s2, 2p5. Again 2p5. This must be 2p6. Total electrons are 5, 6, 7, 8, 9, 10. 10 electrons. So it means this X and Z, they are almost same. There are total 10 electrons and P can accommodate 6 electrons. We will put 6 electrons in P instead of writing 5. So correct configuration is 1s2, 2s2, 2p6. Question number 4. Which orbital in each of the following pair is lower in energy? 2s or 2p? According to our principle, energy of 2s orbital is lower than 2p. And 3p and 2p, 3p is shell number is in shell number 3 and 2p is in shell number 2. And definitely the higher the farther the shell is from the nucleus, the more energy it has. So this is farther, this is closer to the nucleus. So energy of 2p will be lower than the 3p. 3s, 4s, again third shell and fourth shell. Energy of the third shell is lower than the fourth shell. So 3s has or it is lower in energy according to our principle. Draw Bohr model of the following. Question number 5. First one is Bohr model of potassium. Atomic number of potassium is 19 and mass number is 39. So first of all, to draw the Bohr model, we need some information. That is number of neutrons we need, and number of neutrons we will find out by using this formula: mass number minus atomic number. Mass number is 39, atomic number is 19, number of neutrons are 20, atomic number is 19, so number of protons are 19, number of electrons are 19. So we will write, we will first draw the nucleus, protons 19 and neutron 19, 20. Then first shell can accommodate 2 electrons, Second shell can accommodate 8 electrons. Third shell can accommodate 18 maximum and 8 minimum. So we will write 8 electrons in the third shell. Only one electron is left, that we will write in the last shell. So K shell will accommodate 2 electron, L8, M8, and 1 electron which is left. We will put that 1 electron in the last shell, and that will be the N shell. So this is the Bohr model of potassium. B is silicon. Atomic number of silicon is 14. Mass number is 28. First of all, we will find out the number of neutrons. 28 minus 14, so 14 is the answer. Number of protons are 14. Electrons are 14. So we will put in the nucleus proton 14, neutron 14. First shell 2 electrons. Second shell 8 electrons. How many are left? 4 are left. Those 4 electrons we will put in the last shell. So K accommodate 2 electron, L can accommodate 8 electron, and N can accommodate the last 4 electrons which are left. It will go to the fourth shell. In the third shell, sorry. Argon atomic number is 18 and mass number is 39. So number of neutrons is equal to mass number minus atomic number. 39 minus 18, 21. Protons are 18 and the number of electrons are 18. And you can see in the nucleus we will put protons are 18, neutrons are 21. We will put 2 electrons in the first shell, 8 electrons in the second. So 8 and 2 are 10. How many are left? 8 electrons are left. Those 8 electrons will go to the outermost shell. So you can see 2, 2, 4, 6, and 2, 8 electrons. So K shell will have 2 electrons, L will have 8 electrons, and M will have 8 electrons. So there are total 18 electrons in argon. And argon belongs to the group number 8 of the periodic table. So dear students, I hope you understand these questions. Some of the questions from exercise are left. So inshallah, we will continue the exercise in the next lecture. Until that, Allah.